Hi everyone, welcome back to my channel. In today's video, I will try to show you or explain the regularization L1 and L2, or called lasso and rigid. So in many videos, you have seen this regularization, or you heard in many lectures, but I mean, maybe no one is explaining with with numerical examples, like what I have done here in this video. So is this showing you how to understand, let's see, the the L regularization L1 and L2 with simple example. So before going dive into regularization, so when we need to use the regularization, so the regularization is used for the to over, let's see, to minimize or avoid overfitting. So as you can see in this image here, so by the way, regularization, it could be used for regression or classification. So as you can see, this is the overfitting. What does the overfitting means? The overfitting mean is the model is trying to let's say memorize the data instead of learning the general patterns. So, and sometimes in your, let's say, in your, when you train your model, or maybe the neural network, you can see that the training loss function is almost zero, and I mean the cost, while the validation, it's is very high, let's see, the loss function. And this is due to the overfitting, because the model is memorized all the data, but it's not able to let's say learn the general patterns. That would be to discover or detect to able to classify or do the regression, extracting the the continuous value or target value. And this is, for instance, for the I'm using currently the linear regression. And if you are not familiar with linear regression, please have a look in the previous video. It will explain with also very simple example. I mean, with the same this data set here. And as you can see, for the classification, you can see the model is almost try to split the data here. Now, in case if we have in the validation data, let's see, we have a point here, let's see X here. So it won't be able to classify this, because the model is only try to split, or let's see, memorize the data. And now what is the L1 and L2? And as you can see here, this is only a simple diagram to show you what is the L1 norm. So the L1 norm is trying to make some weights zeros. As you can see, for instance, this is the weight is almost zero, and it's used for this, for the for the feature selection, because much some attributes or irrelevant attributes will be zero, so it will be removed from the data set, and only some of these will be used. And for the L2, it's not it's just to make it balance, I mean, not balance, but it's just to see all the weights are, or all the features are important, but it will give them a weight corresponding to their participation in the data set. So this will be used for the as also as a feature selection, but this is not as a feature selection. In the end of this video, we will see what is I mean, a comparison between L1 and L2. So normally this is the equation of the, sorry, the equation of linear regression here. It's because I have two attributes here, x1 and x2. I have beta 1, beta 2, and beta 0 is the, it's called the and y-intercept, or in the neural network it's called bias. And this is our key, our loss function here. We have the normal one before adding the regularization. And for the regularization and L1, we have the absolute value here, adding the absolute value of the weight. And this one here is adding the square of the weights. And now for the gradient descent, we won't use this as absolute value or this as a square root. We will use the derivative. And we will see it. So also these steps are already explained in linear regression video. So please do make a review or have a look at this video. Now let's see. I'm assuming that the weights are in the beginning. I mean the weights or parameters are zeros. So as you can see here, if the betas are zeros, so the y hat will be zeros. So it means the y hat, it will be, for instance, for this person here, it will be 0 0 0 0 0. But here we have 120. So we need to update the parameters so we can get these values or maybe close to these values. So for that we will add regularization. This is beta 1 and beta 2. As you can see, beta 0 is ignored because it's not related to any variable or any attribute. For example, here you can see with the yeah, beta 1 and beta 2. Only beta 1 and beta 2. Beta 0 it's not used because it's not connected to any parameters, or it's just y intercept. Now we have this loss function, and we will add, now we need to update beta 0, beta 1, and beta 2. And for this, we will use chain rule derivative. So OD, again, it's already explained in the previous videos. So in the linear regression, I will add the link in the description. And you can see for the beta 0, it's nothing. It's just actual y minus the y hat. So as you can see, this complete term, it's y hat. Let's see. And for the beta 0, for the beta 1, we will add the multiplied by x plus the regularization. Here's the regularization. And for the regularization, as you can see, lambda multiplied by sine beta 1. So what is the sine beta 1? Beta 1, it will be plus 1 if it's greater than 0, minus 1 if it's less than 0, and 0 if it's 0. And you can see here in the L2, we don't use this here. We just multiply lambda by the value, the beta value. And this is the equations for how to update the parameters. And in this case, I just use lambda, alpha or learning rate as 0.01 for some calculation. And let's say, for instance, we have in the beginning, I said we have assumed that beta 0, beta 1, beta 2 are zeros. So we have y hat is 0. Even here, y hat is 0. Now we will try to calculate the gradient. The gradient will be calculated using this equations here, and also for L2 is this one here. So L1, now the gradient with respect to beta 0 at minus 164, and etc. Now we need to update the parameters, the beta 0. So the beta 0 will be the initial value minus the learning rate multiplied by the gradient of beta 0, for instance. And because it is minus, it will be plus 1.64. And also the same, it will be here because the regularization, it's not used, so it will be the same values here. And now we need to use the new parameters. Let me just maybe increase zoom in. So these parameters here will be used in this equations here. And we will try to calculate now the prediction. And for the prediction, we have this, and we will calculate now the gradient. And again, we will have to update the weight. And we have to, this is the new weight. No, it's false, sorry. This should be, yeah, this is only a copy paste. So we have a problem. So it will be 90.301, and this will be let's just keep it minus 557.82, and this one so we have these parameters now, the value of these parameters, and we will try to continue until we have, let's see, a loss function or the gradient will be close to 0, let's see. And now it's also the same for the L2. So what is the I mean let's see the comparison between L1 and L2. So L1, as you can see, it's a summation of all weights, absolute value, and this is the square of weights. And this is sparse solution. What does that mean? Sparse. It means some attributes or some parameters will be 0. So all of I mean, assume that you have 1,000 attribute, and only 10 are relevant parameters, and this 990 will be 0 0. This is called sparse, and it's used also for feature selection, and there's no here feature selection. Robust to outliers, and this is not robust to outliers because it's used square terms. And I think that's it for today. And I'm quite sure that no one is explaining this with examples. So I also this take much time for me to prepare this tutorial. So please subscribe in my channel and like the video. And if you have any question, just write it down in the comment below. Thanks for watching and see you next time. Yeah, by the way, I just forgot to mention I have implemented the Python code for L1 and L2 without any, let's see, packages. And as you can see here, this is the L1. It's the same example, the same parameters, and it should give you the same result as in the document. And by the way, for the after let's say you are getting familiar with Lasso and the other rigid, you can use also the skyline to calculate the Lasso and L1 and L2. This is, for instance, L1 and L2, but I just added this to you so you can use it, run this and try to debug and evaluate, see what are the values after this operation and etc. This is the same as L2, I mean as L1, and I think this could help. And by the way, I have this also Skyline, and I have the same example, and it should give you the same result. But this is after some iteration, it will give you the right let's say the final coefficient. Yeah, that's it for today, and thanks for watching.